Okay, so it says here the axis symmetry of this graph is at x equals -3 and passes through the points 2, 6, and 7, 21. Okay, so these are some random bits. Oops, what happened to my graph there? There we go. So this graph here says that we are going through, it has an axis symmetry as -3 and passes through the points 2, 6, and 7, 21. So these kind of give me random coordinates. Although the axis of symmetry is important because it does give me the middle. So it gives me an idea where the middle is. And if I know where the middle is, I have an idea what this graph's going to look like. Okay, so I have points at 2 over 6 up, maybe somewhere around here. Okay, draw maybe right about there. And 7 over 21, maybe somewhere around here. And it looks like the axis symmetry is at -3. So -3, maybe somewhere around here. There's my middle. So I get an idea what this graph looks like. It looks like, it's hard to tell, but based on that, okay, and again, these are some random bits of information here. These are not very good bits of information because it doesn't really tell me where the vertex is, but I think the vertex is going to be on this. It's going to be like this. It looks like it's going to open up. Okay, again, it's hard to tell because of the shape of that, because of those 2 points they give us. But we can at least kind of have an idea. Okay, it's good to try to see what this looks like in our mind's eye. Okay, or not just our mind's eye, but to actually, if we can actually sketch it out and see what it looks like. So this is what I'm seeing. Okay, I don't know how accurate this is yet, but what we can see visually, we can then translate algebraically. That's an algebraic truth that we can come up with. If we can physically do it, there's some algebra that matches it. Okay, so let's try to see what we can come up with. So what do we know? Well, should we put this in graphing form, general form, or factored form? Now, all 3 will work, but which one's going to work the easiest? And our preferred choice is going to be graphing form. And since I have some information about the middle, I want to use a graphing form here. Okay, so I'm going to go y equals ax minus -3, so it's going to be plus 3 squared plus q. Okay. In the worst case scenario, I have 2 variables to solve for. I can generate 2 equations with those 2 coordinates. I can solve this as a system. I'm going to see if I can look for some shortcuts here using the symmetry, but really I don't know how useful that's going to be to find the symmetrical coordinates. We can find a point over here. In fact, we know exactly where that point is. That's going to be at -7 and +6. This coordinate here, up here symmetrically, is going to be at -13 and +21. Okay, so it doesn't really tell us anything algebraically about this. It doesn't give me any idea about P and Q yet. So I'm just going to set this up as a system of equations then. Okay, because it doesn't look like I have any other options. So I'm going to plug in my x and y. So my y is 6, when my x is 2. And so I end up with, I'm going to simplify this, 6 equals 49a plus q. Okay, so I just need to come up with one other relationship, and I'll do that by plugging in the other coordinate. Y is 21 when x is equal to 7. Okay, so then simplifying this, I get 100a, sorry, it's going to be a here, so 100a plus q. Well, looking at equation 1 and equation 2, I'm just going to subtract these equations, and I can eliminate the q. So I'm going to do equation 2 minus equation 1, and I'm going to end up with 21 minus 6 is going to be 15. 100 minus 49 is 51. Okay, I think that's right. Sorry, this is going to be not plus 5, is plus 3. So that's going to give me 25a, which then is going to affect this, isn't it? So we're going to end up with 100 minus 25. I'm going to end up with 75a. Okay, and then plus q minus plus q, they cancel out. I can solve for a. A equals 15 over 75, which simplifies to 1 over 5. Okay, so there we go. I've got a value. I still need to solve for q, so I'm going to plug it back into one of the equations. So I'm going to take my a and just plug it into here. So I get 21 equals 100. So I'm going to plug that into a equals 100 times 1 over 5 plus q. Okay, so this is going to be 21 equals 20 plus q. So I solve for q. Q is equal to 1. So there I have my a and q. I've got my equation of my parabola. So it looks like the q value here is going to be at y equals 1. Okay, that wasn't too far off, was it? Okay, so my equation then works out to be y equals 1 over 5 x plus 3 or minus negative 3 squared plus 1. Okay, so there's my equation of my parabola. Okay, so bear in mind this is just the easier way of doing it. You could have done a harder way by using the general form or factored form, but that again creates a bit of difficulty because you're just making things a little bit harder for yourself when you can use the symmetry here of x equals 3, and then we can use our preferred graphing form. Okay, so here's another problem here. Let's sketch this graph. So we want to find points symmetrical to 4, 7 on this graph. So let's just double check, make sure that 4, 7 is on the graph. So 4 minus 3 squared times 2 plus 5, that equals 7, yeah. So this coordinate is on that graph. And this graph is going to be a parabola centered at 3 over 5 up. It may be about there, and it's vertically expanded and facing up. Okay, so we have a graph kind of looking like that. And at 4 over, so here's 3, at 4, we have a y coordinate at 7. So that's going to be 4, 7. Okay, I'm just going to draw my middle line here. The symmetry line is really important. And on the other side of that symmetrical line, I'm trying to find, I'll do a different color, I'm trying to find here this coordinate right here. Okay, that's going to be at y equals 2. Okay, so y equals 2, well, and I've just solved it really. That's going to be, and the way I did it was, I know it's 1 from the middle, so to the right, so it should be 1 from the middle to the left. So my y coordinate has to stay the same, it's got to be 7, and the x coordinate must be 2. Okay, now this one's pretty easy to solve for. How can we generalize this problem? So if I want to generalize this problem, I can do this. If I let that be the position x, I can do this as a calculation for the middle. So if I want to avoid lengths and stuff, because sometimes we get mixed up with what's a length and what's a coordinate, what's a position. So I'm just working with positions. I know the coordinate or position x is what I'm looking for. I have the position here of 4, and I have a middle position of 3. And I'm going to do this. The outside positions, if I find the average or divide by 2, I'm going to get the middle position or the middle coordinate of 3. And I can solve for x here. So I get x plus 4 is equal to 6. And then solving for x, yeah, if my middle is 3 and one of the outside points is 4, the other coordinate must be 2, because these 2 points, the average of these 2 coordinates is always going to give me the middle position. So there it is. That's an algebraic way I can solve for the middle, or sorry, solve for one of the symmetrical points. And that's going to be very important because we're not going to be dealing with numbers all the time where we can count. We need to be able to deal with coordinate positioning.